Hello and welcome for today's webinar, Machine Connectivity in Brownfield Projects. How to unlock Siemens S7 and Siemens S7-300. My name is Andreas Röck and I'm the head of the product management here on the location Nuremberg. The agenda for today will be first, why we should collect data, why we should connect to the devices, why we should bring the devices into an environment. Second topic is a typical scenario, and then the 2 steps to acquire the data from the device. And I will show then also a live demo, how to connect to these devices. And finally, a short summary. At the beginning, why collect data? Data is a prerequisite for the benefits of Industry 4.0 application, such as enhancement for the productivity, efficiency, and flexibility. Smart production also requires the availability of data from different production processes. We called it also process data integration. What are the requirements for all these topics are standards, norms to enable communication between machines and application. And here exactly will be the problem. The biggest problem is to get really the data out of all devices, which will support only maybe legacy protocols or have no connectivity to the Ethernet and so on. And this is more or less a topic for this webinar today, how to enable S7.5 or S7-300 devices from Siemens. A typical scenario is here. We have our controller, which is connected to an Ethernet, which speaks for Siemens, for example, the RFC 1006 protocol, and the data are provided via standard interface, OPC Classic or OPC UA. But we have a big challenge on these old devices. There is no Ethernet interface on the PLC. So a solution is extremely important, especially because the high invest cost for machines and systems. So the customer don't want to change all his complete machine or the complete system only because it has no Ethernet interface, for example, on the S5. And in this case, we need some help from, I will say, some tools or some hardware products. One is the first step to get a Siemens S5 Ethernet connectivity in this old Siemens PLC. On the one hand, we have such kind of in-chassis modules. This is one from Softing, the S5 TCP/IP module, which can be directly plugged in a Siemens device. It's one possibility to get an Ethernet interface out of the Siemens device. The next one is the modern, newer version. It's an S5 LAN adapter. It's a BG module, which will be plugged on the one hand on the S5 BG interface, and on the other hand, we have an Ethernet interface. The most important topic for these devices or for these gateways is the LAN adapter must support ISO on TCP RFC 1006 because this is the most used protocol for connecting Siemens devices. When we have plugged in such kind of module or LAN adapter, we have made the S5 ready for Ethernet connectivity. In addition, also on old S7-300 and 400 Ethernet devices, there's also no Ethernet integrated. For this, there exists some other, I will say, S7 LAN adapter, which you plug on the Profibus MPI adapter. And on the other side, we have also here an Ethernet interface. And also, be take care about this LAN adapter must support ISO on TCP RFC 1006. It's the most used, I will say, protocol for Siemens devices. Now, with this hardware devices, we have made now our PLC, our controller, more or less ready for connecting. Next step is to have a software which is now able to connect to these devices. And here we come to the Datafeed OPC Suite, the all-in-one data integration solution for accessing the data. The Datafeed Suite is split more or less in 3 parts. On the one hand, we have our data sources. On the data sources, we have a big number of PLC protocols included, for example, Siemens, Modbus, Mitsubishi, Rockwell, P&R. And in addition, as data sources, we support also OBC Classic Servers, OBC Tunnel Servers, OBC UA servers, And also we are able to connect directly IoT devices, which are MQTT publisher. In addition, we are able to connect to an MQTT broker via a subscriber. We are able to read out the data from an SQL database or from a data file. These are our data sources from the Datafeed Suite. On the other side, we have our data destinations. We can provide the data which we receive from these sources via standard interfaces, OBC Classic, Tunnel, or UA. In addition, MQTT or to the Siemens MindSphere via MindSphere protocol. We have also integrated a REST client, which is able to put the data to a REST server. We have some database APIs for NoSQL databases. And in addition, we have an OPC interface, which allows us to connect to different kinds of SQL databases. And last but not least, file access, which enables the suite to store the data in a file. In addition, we have here our, I will say, engine part. On the first hand, we have our pre-processing engine, which allows you to, I will say, manipulate the data which you have received from a source. For example, to manipulate the temperature from Celsius to Fahrenheit, or you can also have some mathematical operation on the data, up to some scripting, I will say, language, which is also supported by our pre-processing engine. In addition, we have an exchange functionality, which allows you to transfer the data or exchange the data between different sources. We have a store and forward integrated for the most common data destinations. And last but not least, we have also local items, local data points, which allows some communication between the data destinations. This is our solution for acquiring the data. And in the next slides, I will show you the most common use cases for acquiring the data. First use case, scope of functionality is to act as an OPC UA, OBC Classic Server. We are connecting to controllers, in our case, the Siemens S5 or S7 via the RFC protocol, and provides this data via OBC Classic UA to different kind of IT applications. So accessing the controller, we enabled fast and easy integration of process value into IT systems via the standard interfaces, OBC Classic and UA. And we have also a store and forward function included, which helps us if the connectivity to the client is broken. We store the data, and after the connection is re-established, we will automatically transmit the stored data to the client application. This is one of the most common use cases with the Datafeed OPC Suite. In addition, we act also as an IoT Cloud Gateway. It allows us a simple integration of the process data to our cloud interfaces directly into the cloud. We collect the data via the RFC protocol from the Siemens device and provides this information via PPMP or MQTT or REST interface to the other protocols. And also here we have included a store and forward function, which buffering the data in case of a broken connection and automatically transmit the data once the connection has re-established. This is our second use case. And the third use case is also to store the data for later, I will say, analyzing or verifying the data into different kind of data storage solutions. On the one hand, we have here an ODBC driver integrated, which allows us to store the data in the most common SQL databases, MySQL, Oracle, PostgreSQL, and so on. We have also, we called it NoSQL APIs integrated for the current most common NoSQL databases, MongoDB and CouchDB. The third one will follow in July. With the next release, we will also support the InfluxDB. And last but not least, we are also able to store the data in a file. It can be a TXT, HTML, XML, CSV file. The customers feel free to specify his own format. And in addition, what is also a benefit, we are also able to store the data directly in a cloud-hosted database. It is independent if it's an ODBC or it's a NoSQL API. Why? We are supporting on both interfaces the standard security credentials for encryption. So we can directly encrypt the communication between our suite and the cloud storage solution. So you can directly set up, for example, your SQL database in the cloud, and we are able to store directly the data into the cloud. And also here, we have also a store and forward functionality included, which buffers the data And if the connection is re-established, we will also automatically forward this data to the database in this case. These are the most three common use cases which are used for acquiring the data. And all the same is we read the data from a Siemens S5 or S7. But now it was big part of theory. I will now show you something in a live demo, how easy it is to collect the data from a device. We have here our Datafeed OPC Suite, which is organized like in my presentation as data sources, data processing part, and data destination. On the data sources, we have our different kind of data sources. In our case, we will use the data source Siemens. In this case, we will add here a connection to an S7-5 PLC. On the first wizard page, we have for the most common interfaces a wizard-based configuration. So you will guide it through a wizard step by step to your configuration. In this case, I enter the connection name. For me, I will have the connection active. I select the protocol, in our case S7-5, put here on next, and then I must configure my connectivity to my device. First, IP address. It's the IP address, and then the advanced information for this connection. And here we must select this RFC 1006 configuration. On the other hand, I will use always for my demos to have one connection, but you can also specify if it's a write aloud or read only connection. So you can directly set up here your communication settings. In addition, we have here an important step. You must specify a TSUB. It's a special Siemens notation with this TSUB. And for this, I have specified on my hardware gateway. Oh, sorry, it was write and fetch. And in this, I will make a short interruption and go to the device connection. I have prepared something with our in-chassis module, and here these are the three normal configuration steps for configuring this in-chassis module. Connection name, IP address information, if you want to have a server, TCP, and here's the main topic is the RFC. And last but not least, here we have this TSUB configuration. And here on the S5, you are lucky, you can specify whatever you want as a TSUB. And I have specified this fetch and write, but on the suite, we must have it vice versa. That's why I have here write and fetch. That's all what you have to configure for the communication. Then we have some extended settings. Read optimization, it means we read not only a single DP, we read a bigger block directly from the PLC and split it into the data blocks on the PC itself. You can here enable a cyclic read. In this case, we will read in a 1000 millisecond interval the data from the device. And here you have the possibility to test your connection. My connection is successful. So this is the configuration part for the communication settings. Now we come to an important topic. And here it's a little bit, I will say, not difficult, but here you have to do a lot of steps, I will say, by hand for the address space definition. On the one hand, you have two choices. You can directly add your data points. I will create at first a node, second, and then I will create some data points, for example. This is a counter, for example, and here you must specify it with the Siemens notation. For example, DB5 word 0. This is the way how you can configure your, I will say, address space. This is more or less it shows how your PLC is organized. This is one way, but there exists an easier way. You can also import your address space from a file. I have something prepared. I will select this file. And then I can also import your structure, your hierarchy from a file. To show you a little bit how this file looks like. Just 1 second. It's easy. First, it's a symbolic name, and then the syntax for the DP in the S5. So here you can create your own alias file and can also import it into the suite. It's a second way. That's all what you have to configure for an S7-5 connection. On the S7 connection, it's similar. You have to select at first your protocol, S7 in our case. If someone will have access to a newer PLC, 1200, 1500, we will also support the new protocol. We call it S7-2 protocol, which supports also data blocks in optimized mode. But for our demo now, we are using the standard S7 protocol. On this, we have also specified, like on the S5 connection, the IP address. Then normally you have to specify also if something was changed, the rack and the slot on which you want to access to your PLC. By default, these are the most common values. And here you can also specify if you want to write to the PLC and so on. Here by default, it's the RFC protocol selected. That's all what you have to do here. Next page, it's the extended settings. Here you have the same like on the S5, read optimization, cyclic read, and also the test option. You can test the connection, everything works fine. And now we have the next topic. Here also the address space definition. And here we have a more, I will say, easier way. On the one hand, you can configure it manually. Next possibility is to do it via an import. Or you can also choose the third option to directly import your structure, your symbolic address space directly from a file. We have two possibilities. On the one hand, you can directly import it from an S7P file. It means from a step 7 project. It's one possibility. Or you can also generate out of a tier project with an additional software, which we will provide for free. It's a tier exporter from Softing. You can also extract out of a tier project the information, and since this generated file can be also uploaded to the suite. Next point, you see the programs which are configured in this project. I select the first one. You get a list of all data blocks. I make it easy. I will select everything. Next, need some short time. I have imported now roughly 9,000 data points, and then you see here your complete structure. But now some of you think, oh, I have here some values which are, have no meaning for someone. I will change the symbolic name. You can also change it here by hand. This is, for example, machine 1. You can also do it by hand here, or you can also export this file as this information, change it in the file, and import this file back. This is a second way to change maybe here the naming of your symbolic address space. That's all what you have to configure also for the S7 connectivity. So quite simple, quite easy. Now I have configured the S5 and S7 connectivity. What I must configure now is the UA server. We find the UA server on the data destinations with all the destinations which I have mentioned in the previous slides. Here you can select or you can activate the OBC endpoint. I will copy my endpoint information. You can change if you want here the security mode. We support all the current available security modes from the foundation. You can also specify additional users. But for our demo, I will use the anonymous user. Now we have here an UA client, a demo UA client, which we will provide also with a suite. So you can test the most topics. I put here my, oh, I forgot something. Sorry, I must start at first my application. Sorry for this. I was a little bit too fast. Now I have started my application. Now I can validate my connection. I receive the certificate, accept it, and then I have a connection to the Datafeed Suite. Here I see now my different, I will say, data points. This is machine 1, for example, or we can also get access to the S5. This is 2 values. And now we see the information directly what we receive from the PLC. This value 1, it's for example a counter which changes every 5 seconds. Here we have a second value. If you want, you can also write data back. So this simulates more or less your application which receives now the data directly from the suite, more or less, and the suite receives the data from the S5. So it's quite easy, quite simple to enable a Siemens S5 to provide this data. This was the first step, to provide this data via UA. Now we come to the second step, to provide this data via MQTT. It's also quite easy, simple. I will stop my application first. Then we go to the data destination MQTT. Add here a new connection to a broker. You specify a name and client ID. It must be a unique one. For some cloud applications, you must specify here a dedicated client ID. That's all. Then you have the communication settings. On my demo, I have a local running broker, which is on the local host available. So I must not change here anything, but you can also specify here encrypted communication via SSL or also WebSocket access. You can also specify sensor certificate stuff and also the user authentication if needed. Here we have our connection test. It's also successful. Then we go to the next page. Here we must specify a topic under which we want to send the MQTT message. For MQTT, everything is going through a topic. It's more or less the message headline. Yeah, you can compare it with message headline. That's okay. In addition, you have some additional settings for MQTT, including also store and forward for MQTT. But for our demo, I will make the easiest, I will say, communication settings. I must press here only finish. This was the part with the MQTT connection. Now we must define which data points we will send through MQTT. And this is done via one of our data processing engines. Here we must activate Exchange. We select in our case this first value from this S7-5, not S7-S5 connection, and I want to publish it via this MQTT broker connection. Add here, I have here now my new entry, Siemens value 1 will be published to the broker to the topic test. I have here the item trigger. I can select also timer trigger or variable trigger, but for the demo, I will use the item trigger. That's all. Save and start. Oh, now it started. Now I will catch my MQTT client. I will connect to my broker. It's working. I will now subscribe to the test topic. And if everything is configured correctly, I will receive now in 5 seconds interval the data from the, I will say, S5. So it's also quite simple, quite easy to get the data from an S5, provides this data through MQTT MQTT to a cloud. What does it mean finally? 10 minutes for me, for you maybe 15 minutes to configure your connection S5 and also UA and MQTT. So this is more or less the end from my live demo. I will switch back now to my presentation. Short summary, the Datafeed Suite with its various options is the ideal product for data integration solutions to receive the data from a Siemens SIMATIC S5 or S7 controller. If you need some additional information or a free trial version of the suite, you can find it on our web page on this link. Especially the trial version, it's a good option to start to configure everything to test if your solution is working with our Datafeed Suite, because the trial version is running 72 hours. And after the 72 hours, it's only needed to restart the application and then it runs again 72 hours. And finally, if you have configured everything, it's a good topic. We have here on settings an option which shows you normally which license is needed. I have already integrated a license, so this is a license which I have integrated, but otherwise, if you have running in demo mode, you see here exactly which license you must purchase at Softing. Then you have entered the license and everything works. If you have any questions, contact us at info@automation@ softing.com. In addition, I will say thank you for your attention, and I will now answer the questions from you. Now, please ask your question. We have already one question here. If someone installs this S5 card into the PLC, is there any necessary modification in the PLC hardware PLC program? No, there's no changes. Only plug in into the PLC and some data will be received. You must only have, in some cases, a connectivity from here to the S5 controller module. That's all. There exists a special cable which you must use in this case. So no change of the program is necessary. So if you do not have the program, because it's an old system, you lost the program, or some manufacturer of the machine has the program, it's no problem. You have to only install the card, and then you are able to get the data from the S5. Is there any limitation in the number of MQTT connections? It's the next question. We have two limitations. One is the limitation of the number of connections itself. So we have the possibility to configure up to 50 MQTT connections. We have a second limitation. It's a maximum of 1,000 data points which are possible to use in our add-ons at all. Add-on means MQTT, database, to file exchange functionality. In all this, I will say functionalities, add-ons, you can only use maximum 10,000 data points. And the number of connections is limited to 50. Can this method work for password protected S7-300 systems? I never heard from password protected S7-300 systems. Sorry, I know only from 1200 and 1500 password protected systems. And for this, we currently not supporting the password protection from 1200 and 1500. It's on our roadmap for next year. But S7-300, I never heard it. Some additional questions. The MPI Ethernet adapter has its own IP address. You must specify for this adapter your own IP address. It's independent of any PLC IP address. If you need more MQTT connections, it's possible to install 2 OPC Datafeed Server and the same PC. Yes, but there is not needed to install 2, I will say, Datafeed Suite. You can run multiple Datafeed Suite configurations in parallel. We called it configurations. Each configuration has its own, I will say, thread and everything. It's a complete separate instance, and we support up to 50, I will say, configurations. So the total number of MQTT connections is 2,500, but this belongs only to the connections. The total number of data points, it's still limited of 10,000 for all the configurations. License cost, rough numbers. For this demo, which I show, including the MQTT, the costs are 2,400 euros roughly. Any additional questions? No? So I will say thank you for your attention, and I wish all of you a nice.
Exactly.
We have, can the software works with IPH link S7 Plus? Yes, it will also be able to connect to the IPH link S7 Plus via the RFC 1006 protocol. It's also supported. It must be not a softing, I will say, Ethernet adapter. It can be any kind of Ethernet adapter which supports this RFC 1006 protocol. So still wait, maybe some additional ones. No? Okay, then again, thank you for your attention, and I wish everyone a nice day. And I hope you join one of our next webinars. Bye, guys.
Bye bye. Bye from Munich. Thank you, Andy.